Hello everybody, this is Amell Peralta with another coding interview preparation video for you, and this time I'm going to show you how to solve the kth largest element in an array problem. So, find the kth largest element in an unsorted array. Note that it is the kth largest element in the sorted order, not the kth distinct element. For example, they give you this array that is not sorted and they want you to find the second largest element. So the first largest element is 6 and the second largest element is 5. So the method returns 5. Here they give you this array and they want you to find the fourth largest element. The first largest element is 6, the second largest element is 5, the third largest element is 5, and the fourth largest element is 4. So your method returns 4. And you may assume that k is always valid, so k is always between 1 and the size of the array. So how can we solve this problem? There are several ways to solve this problem, and I'm going to show you those ways. The first one is simple. You can sort the array, and when you sort the array, if you sort in ascending order, then you can return the element at position the length of the array minus k, and that's going to give you the kth largest element. Sorting the array is going to take time big O and log n, where n is the number of elements in the array. So the time complexity of the algorithm will be big O and log n. So without further ado, I'm going to show you how to write the code. First, arrays.sort nums. We sort the array and then we return the element in the array at position nums.length minus k. So we sort in ascending order, and then the kth largest element will be the element at this position. Let's run the code. It seems to be working fine. Submit the code. Okay, perfect. So this is working perfectly, but the time complexity is big O and log n. Can we do better? And the answer is yes, we can do better. So we can use a data structure like a priority queue. In the priority queue, there are two types of priority queues: the minimum priority queue and the maximum priority queue. In the minimum priority queue, all the top element is always the minimum element in the minimum priority queue. So, and we can remove the top element in time log k time, where k is the number of elements in the priority queue. And if we just want to retrieve the element without removing it, it just takes constant time. So we can actually write a function, we can actually write a loop, and every time we go through the array from left to right, and we put the element in the priority queue. And we maintain the invariant that all the elements in the priority queue are the biggest elements that we have seen so far in the iteration. So if we see that the priority queue, the size is bigger than k, the size of the priority queue is bigger than k, we remove the top element in log k time. So by the end of the iteration, the priority queue will contain the k largest elements. And then the top of the priority queue will be the kth largest. So without further ado, I'm going to show you how to write this solution. So we need a priority queue of integer, q gets the value of new, priority queue of integer. Then I iterate through the array for integer num in nums. Every time I'm going to put the element in the priority queue. So q.offer num. And I'm going to check if the size of the queue is already bigger than k, then remove the top element of the priority queue, q.poll. So by the end of the iteration, the kth largest element will be the top of the priority queue. So return q.pick. This is going to retrieve the top of the priority queue, and that's going to be the kth largest element. And this solution is going to take big O and log k time, which is better than the previous solution that was big O and log n time. Run the code. Seems to be working fine. Submit. Okay, perfect. So this is working perfectly. The only question is, can we do better? And the answer is yes, we can do better. So in the next video, I'm going to show you how to solve this problem using the selection algorithm. I'm going to show you how to solve this problem in big O n time. Because sometimes the interviewer, even though the solution is working perfectly and the time is not bad, the interviewer might ask you, what if you wanted to do it in linear time? How can you do that? So in the next video, I'm going to show you how to do that. So please press the like button. Please don't forget to subscribe, and see you next time. Thank you.